And for the second one, we have that the diagram below shows a circular clock face with center O, which is this guy there. The clock face made in hand has a length of 10 centimeters, it's this line here, and the clock face our hand has a length of 6 centimeters, that is there. At 4 o'clock, we have point A and point B, which is what it says there. See? All right, so all the information that is given to us is already drawn into the diagram. It's always worth double checking that. Awesome. For part A, we have find the size of angle AOB in degrees. So when it says AOB like that, and it puts the little sign on top of the O like this, it means it is asking for this angle here. Awesome. So what the hell is that? All right, for part A, there's a couple of ways to solve this, and I'm going to choose an approach or a method that helps for what's coming. See, so part C is going to be very similar. Again, there's a lot of ways to solve this, but just to be practical and efficient, I'm going to show you this way. So, one of the ways you can approach this is to ask yourself, all right, so from my origin to, let's say, 1, how many degrees is that? From my origin to, let's say, 2, how many degrees is that? And is there a way I can make a formula to find that out consistently? Well, one of the things that we know is that from here to here, it's 90 degrees because it's a right angle, ¿cierto? From here to here, it's another 90. From here to here, it's another 90. And the last bit is also 90. You add those 490s up, you have 360 degrees. So 360 degrees is what goes around the circle. See? That's why when people say do a 360, you go around in a circle. Wow. Anyways, moving on. Point is, a circle, when you go all the way around it, it is 360 degrees. So, if we're trying to find the angle at 4, ¿cierto? We can go by whole numbers, right? So if I figure out how much angle I have when I reach 1, I can keep going until I reach 4. See? I know it sounds a little bit weird. It's going to make a little more sense in a second. Point is, if you take 360, which is the total amount of degrees of a circle, you divide it by 12 because we have 12 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is going to be a big hint. See? So 360 divided by 12 is going to give me 30. So what does this mean? Because I divided by 12, it's telling me that at each one of these, like, whoops, that didn't work out as I expected. At each one of these numbers, you have 30 degrees. So from here to here, I have 30 degrees. From here to here, I have another 30. From here to here, I have another 30, etc., until we reach number 4. See? And so here I have 4 30s, so I have 4 times 30. It's going to give you 120. So part A is 120 degrees, and that is the method. See? The biggest thing I want to show right now, and as you see that it's color-coded in green, I divide by 12 because there are 12 numbers. Okay, keep that in mind. For part C, it's going to be very helpful. Got it? So that is the approach for part A. For part B, we have find the distance between points A and B. So that is making reference to between A and B, it would be this right there, right? And well, technically B is, oh well, yeah, it would be just that from here to here, see? And we have this angle here, 120. So we have a triangle that looks something like this. We have one angle and two sides between that angle, see? Now, that's an important word that you just said. We have two sides between an angle. Whenever that happens, you have to think of trigonometry and a certain rule, a certain formula, okay? Point is, if you're trying to find the missing side, which is this one here, ¿cierto? What are the tools that you have? Pythagoras theorem if it's a right triangle, or trigonometry in every other case. So we open up our formula booklet, we go to the part of trigonometry, and we see what we can use. I've explained this a lot more in a lot more detail in my other videos, but as you see, the sine rule works in pairs. See? Remember that little a and big A makes reference to the following. You have big A being the angles, and little a being the sides. Okay, so just to make it more visually appealing, it would be something like this. See? So right now we have a triangle where we have two sides in between, right? So let's say A and B. Whoops, that's little b. And we're missing little c. Mm-hmm. So that's when the cosine rule kicks in. See, I cannot use the pairs here because I don't have enough matching pairs to plug in like this, but I can use the cosine rule in every other case, right? So I know the cosine rule looks kind of nasty, but just trust it and follow what it says. See, so what it's saying right now, right here, is saying, okay, you need to put the side that you don't have, the two other missing sides, which is what we have here. Cierto? The two other missing sides are there. So that would be A and B. The 2AB, I have it as well. And cosine C is the angle of your missing side. I'm going to say that again. It's the angle of your missing side. It's the angle of your missing side. So, bada bing, bada boom, we can use the cosine rule. All right, I know I explained that a little bit fast. In some of my other videos, I go a little bit slower. But just so you know, that is the formula I'm using. I'm going to put it in my other monitor, but just trust me, that is what I'm doing. If you go ahead and plug it in, it's going to look something like this. You will have that AB, which is right here, cierto? A to B, squared equals 10 squared plus 6 squared minus 2 times 10 times 6 times cosine 120. See, so I'm just following what the formula booklet was telling me. You solve this, you end up with AB being equal to 14. Do not forget the units, centimeters. All right, so that is for part B. See, nailed it. We keep going. Oh, also before we keep going, this is worth 3 points. So one of the points is, showing some sort of work. The other point is probably using the formula. And the third point, which is why I'm talking about this in the first place, is the units, okay? Sometimes the units can be a whole ass point. Don't forget it. It's important. So it's also worth looking at how many points the answer is worth as a quick reminder that, hey, put your units, see? So yeah, don't forget. Cool. Here we have, for part C, between 4 o'clock and 4:13, right? So right here, it's going to be 4:13. The endpoint of the minute hand rotates through an angle theta from point A to C. Awesome. That is illustrated in my diagram. So I need to find the size of the angle theta in degrees. Now, if you recall a little bit from part A, right, we divided by 12. So take a moment and remember, why did you divide it by 12? You divided by 12 because there were 12 numbers here. So you took that 360, divided by 12, bada bing, bada boom. You figured out that every time you hit one of these big numbers, it's 30 degrees. That was our strategy. Our strategy here is very similar, but slightly changed. We still have 360 on top because there are 360 degrees going around, but my denominator is going to change a little bit, right? And so in this case, I can't do it by 12 because this value that I'm trying to find here isn't aligned with any of the big numbers, see? So what you actually have to do is align your formula with the little numbers. What do I mean by this? I mean by 401, 402, 403, 404, 405, 406, 407, 408, 409, 4010, 4011, 4012, 4013. So if I keep going, adding all of these little, whatevers, you're going to notice that there is a certain amount of them. See? From here to here, I have, dang it, why does that not work? From here to here, I have 5. From here to here, I have another 5. See? I'm talking about the minutes. So how many minutes are there in this whole clock? There are 60 minutes in this whole clock because it is showing a whole hour. ¿Cierto? So if you go ahead and do that, this is going to give you 6. That means that for every minute, this angle here is 6. Which is no different than when we said that for every big one, we have an angle of 30. It's the same thing, just that way smaller now. See? So I have 6, right? So this is like 6 angles per minute, if you want to think about it. It's a weird way to put it, but intuitively, I'm sure it makes sense. So you get 6 angles per minute. Since we're talking from 4 to 4:13, that is 13 minutes. Bada bim, bada boom, theta is going to be equal to 13 times 6. Theta is equal to 78. That is part C. For part D, you need to calculate the length of arc AC. So first of all, what the heck is it even saying? When it talks about length, it's going to be a sort of distance. And when it talks about arc, well, an arc looks something like that, ¿cierto? So it's going to be talking about this arc here. It's that distance. First, I will talk about a common mistake, then I will show how to solve it. A common mistake here is to say, well, this is a triangle, ¿cierto? It's not a triangle. A triangle would be what is drawn in green right now. An arc has a sort of curve to it, so now it's not a triangle anymore. It is indeed an arc. Okay, how the hell do you find the length of an arc? Well, thankfully, and once again, we have our formula booklet. It's very important that you get familiar with this guy. Okay, when you have your test, the IB exam, you're going in with your brain, your pen and pencil, a whole lot of confidence, and the formula booklet. Okay, you gotta get used to the formula booklet. The formula booklet has length of an arc and area of a sector. Right now we're looking at length of an arc. Okay, it asks for the angle, the length, and r, which is radius. Okay, pi is, well, you know what pi is. It's in your calculator. Don't worry about it. See? So that is the formula that I'm using, just so that you know. So for part D, using that formula, I'm just going to write it out real quick so that we are all on the same page. It looks like this. So I'm going to plug in theta, which we found out from part C is 78, divided by 360, times 2 times pi, r, which is radius, it's this guy here, times 10. All right, so whatever that is for part D. So length is going to be, trust me on this, just about 13.6135. All right, awesome. And because it is a length, we can, or a distance, we can put the units as well. That is for part D. For part E, calculate the area of the shaded sector AOC. So again, formula booklet, look at that, area of a sector. So now you're starting to realize, okay, this part is pretty easy, right? Well, the hard part, or the complicated thing, is understanding how the formula works, and also keeping in mind that this is actually a formula booklet. See, I feel like a lot of times people miss points just because they're not familiar with the formula booklet, and I think that is something that you can very easily, learn or fix or whatever. That it? So area of a sector, as I just showed you, looks like this. Theta divided by 360 times pi r squared. This big A represents area. See? So I'm just going to go ahead and plug in, right? So the area of my sector is going to be equal to the theta that I defined, which was 78, divided by 360 times pi times r squared, we said was 10. So I plug all of that into my calculator, and you end up with just about 68.0678 centimeters. Small detail, it's not centimeters just like this, it is centimeters squared. Quick tip, if you're talking about distance, it's going to be to the power of 1, right? Which you usually don't even write. If it's area, it's going to be to the power of 2. If it is volume, it is going to be to the power of 3. So yeah, rule of thumb. Awesome. Then they tell us that a second clock is illustrated in the diagram below. The clock face has a radius of 10 centimeters with a minute, and our hands both of length 10 centimeters. So from here to here, it is 10. From here to here, it is also 10. The time shown is 6 a.m. The bottom of the face is located at 3 centimeters above a horizontal bookshelf. And so those 3 centimeters are depicted right. Dang it. I don't know why that doesn't work. They are depicted right here. Those 3 centimeters. Awesome. F, write down the height of the endpoint of the minute hand above the bookshelf at 6 a.m. And so the height for part F of the endpoint of the minute hand, so it's this guy here, above the bookshelf, so the bookshelf being here, it's going to be this whole height. See? So this whole height is going to be the 10 plus the other 10 plus the 3 down here. So all of these added together would be 10 plus 10 plus 3, 23, do not forget the units, centimeters. That is part F. Later on, they say that the height h in centimeters of the endpoint of the minute hand above the bookshelf is modeled by the function blah. All right, so that is for the function. where theta is the angle rotated by the minute hand from 6 a.m. And to find the value of h when theta is equal to 160. So all we really have to do here is, well, plug in theta equals 160 and find the value for h. So h when theta is 160 will be this. 10 times cosine of 160 plus 13. It's literally that. So h when theta is 160 is going to be 3.60307, do not forget the units, centimeters. So again, part G was simply just plugging in. All right, and then for part H, they tell us that the height, G in centimeters, of the endpoint of the hour hand above the bookshelf is modeled by the function blah. See? So very similar to what we had in part G, but now we have a new function for the hour hand, and they tell us that theta is the angle in degrees rotated by the minute hand from 6 a.m. And for part H, we need to write down the amplitude of G. So what the hell is amplitude? Let's start with that. Amplitude is the following. And all of these sine, cosine, and tangent functions, you have something that goes like this. Visually, it's pretty much always like this, and it's never ending. See? And so the amplitude is something that cuts right through pretty much the middle, or so to say. And it's going to be the distance from like that middle to the minimum and that middle to the maximum. So both of these orange lines that I just drew, they are both amplitudes. See? They are both amplitude, and that is the idea of amplitude. See? So some of the other examples could be maybe here to here, here to here, etc. It's very important that it's from the middle to a maximum. See? It's also important that these are the same value, right? They have the same distance covered. So that being said, let's go back to H. We need to write down the amplitude of G. So you can figure this out manually, or you can do it really quickly just by knowing like the general sort of form of the cosine function. And so the cosine function, whatever's in front of the cosine or sine is always going to be your amplitude. So this, in absolute value, is going to be your amplitude, always. Quite literally always. And so absolute value makes anything turn positive. For example, absolute value of -4 is going to be 4. Absolute value of -7 is going to be 7. Absolute value of a already 7 is just going to be 7. See, so whatever's negative turns it positive. So you get the absolute value of whatever's in front of your cosine function, and that's going to be your amplitude. So in this case, you can literally just say, yeah, the amplitude is 10. Bada bim, bada boom, you're done. You can also do it manually, as I was saying earlier, which is just by graphing, finding out the minimum, finding out the maximum, and finding like the difference between the two, dividing by 2, right? Now that was a lot of blah blah. Let's see it in action. Here I have decimals. You can do it in your graphing calculator. I'm just going to show it here because it's a little bit faster. But as you see, here I have this minimum here with the point 0, 3. So let's say here is 0, 3. And we have this guy here, which is 12 pi, 23. See? So this point here is going to be 12 pi, 23. So point is, what is this distance here? Like this whole height. This whole height has to do with this 3 and this 23. So if I do 23 minus 3, that's the whole height. See, it's 20. So that means the whole thing in red is 20. So how much is each of the blues? Well, 2 blues give 1 red. So 20 divided by 2 gives me 1 blue. See? And 1 blue we said was 10. Same amplitude as here. So that's how you find it manually. And the sort of quick way is by, something they show you in class. It's not in the form of booklet. But more importantly, if you know what amplitude is, you can figure it out. So you can graph it, work from there. So that is the more important part here. So amplitude is effectively from this middle to the maximum or from this middle to the minimum. It's that distance. Do not confuse it with the whole height. Common mistake. Moving on, we have the endpoints of the minute hand and the hour hand. So it's the minute hand being, this guy here, and the hour hand being that guy here. At some point they meet, see? And they meet when theta equals k. So, of course, we need to find the possible value of k. Smallest possible value of k. There's a couple ways to approach this, and what I consider most intuitive is the following. This is the one for the minute hand. This is the one for the hour hand. And so if you go ahead and equal them to each other, that is going to be wherever theta equals k. Quite literally. See? So if I go ahead and equal them to each other, we will have h theta, which is the minute one, right? Minute one, being equal to g theta, see? Which is the hour one. Why do we do that? Because we are trying to find whenever the minute hand and hour hand meet, see? So that is why they're being equal to each other. I'm going to go ahead and plug in and see what happens, see? So if I go ahead and do that, I will end up with something that looks like 10 times cosine theta plus 13, which is this first guy here, equals negative 10 times cosine theta divided by 12 plus 13. See? So this is h and this is the g. See? So I need to do this and end up with theta equals something. See? Now whatever that theta is going to be the value that I want. However, many people at this stage get very confused on what to do. See? You can use cosine inverse. There's a couple different ways to solve it. But I think that especially when you face a problem that you're not sure how to solve, like which functions to use, etc., to get your variable alone, you can always use the calc intersect trick. See, I have a whole video that explains it in depth, but basically you're gonna call all of this y1, you're gonna call all of this y2, you're gonna do calc intersect, and whatever that intersection is the value that makes this thing true, which is making them equal to each other, which is what you're trying to find, ¿cierto? Whichever value of theta makes this equal to each other is what you're trying to find for this last part, part I. So let's see it in action. Let's not make this just blah blah. Y1, as I said, is going to be this first one that I already put. So negative 10. I'm just going to rewrite it so that we're all on the same page. Negative 10 times cosine theta. Theta, I'm just going to put it as a variable. All of this plus 13. Y2 is, oops, sorry, this first one is not negative. Apologies for that. The second one is negative. We have negative 10 times cosine parentheses fraction theta divided by 12 close parentheses, all of this plus 13 as well. And we're going to go ahead and calc intersect. See, so calc intersect, see what happens. So there's one of my functions. There is the other one. All right, and so now once we do the calc intersect, we will notice that the calculator is asking for three things. First of all, it's asking for what is your first curve. As we can see, this first curve is the one that has, well, the more curvy parts to it, right? So we're gonna agree to our calculator with that. Our second curve we can see is the long one, which is the hour hand, right? Because it increases in height much more slowly. So yes, we agree with our calculator. And now it asks for guess. Now the purpose of guess is to ask your calculator which intersection you want, right? So if I put guess over here, it's going to give me that intersection over on the right side. Now the big question now is which intersection do I want and which one is actually the smallest. So intuitively, all of us would say, well, whatever is most on the left is the smallest, right? So I'm going to go ahead and pop it over here, and we get an answer of 166, comma 3.29, right? Now let's hold that thought for a second. Go for the one that's right next to it, and the one right next to it is 196, comma 3.4. Now, it's always very important to interpret the context of your answers, right? And so, for example, this first one, which I will now draw in, let's say, blue, right? Is telling me that when the minute hand reaches an angle of 166, which would be around here, right? We're going to have the minute hand going like that. So I'm just going to mark MH for minute hand. it will be at a height of 3.29. So the 3.29 is shown here, right? And this intersection goes to show that the hour hand, which as we saw in our graph, grows much more slowly, right? Will be somewhere around, let's say here. So this would be the HH, my hour hand. And it will also have a height of 3.29. So what's in blue right now is my first intersection, right? Wherein, although they have the same height by this 3.29, right? They're not on top of each other. And what we're trying to find over here is whenever the endpoints of the minute hand and the hour hand meet each other. You have to keep in mind that all of these functions we're working with the idea of height in mind, right? And so although these have equal height right now, the context of the problem does not tell me that they are actually on top of each other. They will be on top of each other later on, which I am going to mark in, let's say, orange, right? So later on, when it reaches 196 degrees, which is going to be, I don't know, way over here, right? Maybe there. My minute hand is going to be here, and my hour hand as well. And so the answer actually is going to be 186, 3.4. Essentially, and this is probably one of the hardest problems of at this level, right? The context matters way too much for this problem, and you have to keep in mind that this is all in terms of height. See? So although the height is the same, the visual diagram is always going to be helpful. The fact that they have the same height does not necessarily mean that they are on top of each other. In the second scenario, they are. See? But in the first scenario, they are not. How do you know this? Because the minute hand right now is behind the hour hand. See, the minute hand is trying to catch up to the hour hand. That means that at 2 points in time will they be the same height. Once, as I saw in blue, and another time as we saw in orange. In blue, they have separate heights. In orange, they have the same height because they are on top of each other. So, that being said, that is how you solve number 2.